Good morning. So I know you guys have already had a full day, it sounds like, of talking about AI, and I'm going to spend some time this morning going through what AI is to a degree and where we're going with it. Now, with that said, how many of you currently are data scientists? Okay. How many of you are engineers? Nice. All right. How many of you are business people, business leaders, project managers, some element of marketing? It's great. I'm lumping you all together. So we have a good mix here today in terms of representation, and I know all of you are asking questions about, how am I applying this going forward if you already are applying it, or how should I be applying AI into my current company? Because frankly, it's all the rage. Everyone's talking about it, right? It seems to be everywhere. Thank you for the introduction. So, as Julia mentioned, my name is Melanie Warrick. I'm currently a senior developer advocate at Google. I work on cloud and I work on machine learning. And prior to that, I was working on an open source neural net platform known as DL4J. And before that, I was working at change.org implementing machine learning in production. So I have a little bit of a background in this space, and I've been talking about especially deep learning and AI for the last couple of years. And when we talk about it, AI, it's exciting, right? It sounds exciting. It's got a lot of hype. It's got a lot of media attention. And Andrew Ng, who's a well-known leader and researcher in the space, said this year that it is the new electricity. That sounds extremely exciting, doesn't it? It's ultimately saying it's going to be the energy source, this energy source that's fueling where we are going, what's going to be happening next. It's driving things. It's going to drive innovation. But what exactly is artificial intelligence, right? I mean, it sounds nefarious. It sounds really kind of like it's going to save the world. Stop being afraid. Stop being afraid that the world's coming to an end. Now, I'm pretty sure most of the people in this room right now are not thinking the world's coming to an end, that we're having Armageddon from it, that the machines will all turn malicious and turn on us, or just be really stupid and do something stupid and kill us all off. Hopefully none of that will happen. And I think there's also an understanding that's starting to shift in our society that it's not about taking all of our jobs away either. So I want to try to take that perception, that fear, and also that extreme hype of it might save us all, and sort of shift the conversation, because there's a lot of hype right now. It's so easy to get excited about it, and it's so easy to understand that this is at the height of the curve. We are at the top of this curve right now of hype. We've been there before. AI is not new. This came about in the 50s. And if anything, some people can argue that it came before that. And it had a lot of excitement and expectations and disappointment, and we dropped down. It happened again in the 60s or in the 80s and 90s. And it's different now. It's different because we're starting to see some real applications. There's a reason for the hype. But the hype should start to look at it from more of a perspective that it is a foundational piece of a larger picture. It is playing a role. Right now, it's playing a role that's driving us to this excitement level, but it is going to be this fundamental building block that we will see more achievements and advancements built off of. There's a person that has stated in Silicon Valley, it's known as the Amar's Law, that is saying we have a tendency with technology to overestimate in the short term, but underestimate in the long term. We look at things like GPS that was initially conceived of back in the 70s, and we didn't really realize the advancements there until the 90s. Or you look at machine translation, where in 1957, there was an actual breakthrough by Georgetown in terms of taking 60 phrases that were Russian phrases and using a machine to convert that into English. They were thinking, hey, in just a couple of years, this translation problem is going to be completely solved. We have this habit where we see a breakthrough and we think, okay, we're going to now take off into a spaceship. But the reality is it doesn't go that quickly. A lot of people raise their hands when I ask who was an engineer in here, and you know this. You have this dream of where this is going, and it takes a lot of trial and error to get there. Machine translation has seen advancements. We have started to achieve things that they were imagining. We're not fully there yet in terms of solving this problem. But I mean, in 2014, that's when Microsoft was able to implement into Skype this ability to do almost real-time translation on several languages. And at this point, multiple companies, like my company, are able to translate over 100 languages. Like I said, not a fully solved problem, and we didn't get there within the day that this was solved, but we're making progress. It takes time, it takes effort, and it takes being practical and realistic about what you can really achieve in AI. What is AI though, right? Where are we at right now? And I'm sure all of you have your own understanding of what that means, especially since many of you are working in the space. Where it originally came from with John McCarthy back in the 50s, he coined the term and he said it's the science and engineering of making intelligent machines. Seems simple, but what is intelligence? I saw a talk given last week, actually, and the guy started off with this great part where he just started asking everybody, do you think humans are intelligent? Do you think dogs are intelligent? Do you think amoeba is intelligent? Do you think your toaster oven is intelligent? And then he flipped it to consciousness and asking you, what do you think is conscious? You know, do you think this is intelligent? Do you think this is conscious? Conscious is a hard one to define because we don't still really know what's going on up in our heads and how it works. Intelligence, we can go back and forth. Everybody's kind of a little different in how they define it. What we're trying to achieve when we say artificial intelligence is technology that can make decisions. Maybe human-like, but it can reason and have some ability to improve itself and make decisions, and not with an explicit roadmap of exactly how to get there, but with a more generalized, probabilistic approach. So what I like to do to help make sure we're all on the same page when I'm talking about AI is to take it and discuss it in this more categorical form. We have narrow, where narrow is having technology that can solve specific problems. So games are a great spot to talk about because back last year alone, DeepMind achieved with AlphaGo the ability to beat some of the best players in the Go game. And just recently, we had OpenAI's success with Dota 2. But you can talk about AI from the standpoint of solving specific problems like the self-driving car, which is a popular topic to bring up, or machine translation, like I just mentioned. So it's solving explicit, narrow-focused problems. When we talk about AI, especially from the media standpoint, many people will immediately think to something that is human-like, that generalizes, that this is what's known as strong AI, this ability to have AI that can solve multiple broad-range problems, understand, reason, think. Will it have emotional IQ? Debatable. If we could really define that into a computer, we'll see. But this is what people are thinking about when they talk about general AI. It's not what we have right now. And the thought is that if we could get to this point, then we will immediately, or almost immediately, move over to what's known as super, or I'm going to forget the term, singularity, where it's technology that can reason and think above and beyond what a human understands. And this is where we jump into, it will kill us all, or it will make us live forever. We don't know what that looks like. We can't know what that looks like, because it's supposed to think above and beyond what humans can understand. So these are the categories when you start to talk about AI that helps to get you centered on ways to approach it and understand it for intelligent technology. And as I mentioned, what we have is narrow. We know this. And what it is when we break it down is it's really fundamentally like any kind of problem you're trying to solve. It is inputs, computation, and some type of result, some kind of decision. We have our basic inputs for humans, and we're working hard to make it so that technology can take in those inputs. But there's a broad spectrum of which we can have data being inputted into our technology. And then there's the computation part. This is where, frankly, it's math. It's a lot of math in different fields of study. And then there's the reaction and the decision. So from the data standpoint, they were estimating that we're close to creating around 10 billion megabytes of new data per second worldwide. It's like 1.7 million megabytes that are estimated per person by 2020 that will be generated. It's a lot of data that we're trying to generate, that we are generating, and that we're capturing. And then the question is, how do you process that? That's why we need machine learning. We need it to be able to help us process that kind of data. And then it's the computation piece. This is where it really happens. This is where we abstract it, where we generalize it. We allow ourselves to take this and form it into something useful. And we're doing things with machine learning. This is where we're seeing most of the actual advancements in the subject. But of course, it's usually combined with some type of statistics and probability model. We have fields of research around generative algorithms. And we're using, of course, graph theory in some way, shape, or form. Usually something like this is being combined in different ways to solve problems. And I love to throw in quantum computing at the end. Not to say that it's really as advanced yet. It's still very early on in terms of where it's at. But it is being explored for things like search. It's being explored for image analysis. It's seen as this potential. It has a lot of potential in terms of where it will take us for AI. And as I mentioned, we have the ability to look at things and have great ideas, and it takes time to fully realize them. We didn't just get there when we came up with the idea. It takes time. Quantum computing has the potential. It's exciting. We're not fully there yet. But these areas combined, as I've said, they're what allow us to do the computations we need for our machine learning to be successful and for us to achieve AI with narrow AI. And in case you haven't already had this perspective, I like to sort of level set from the standpoint of AI, the general field. Machine learning is a set of algorithms that you use in AI, but not the only one. And deep learning, for those out there, I'm sure most of you have been talking about this. It's one of the more popular subjects because it has seen such an advancement in the last year or so. Deep learning is one algorithm in the machine learning space. Once you've done your modeling, once you've got a model that works, then you have your results. And the results look like the medical field, where we're seeing, medical imaging analysis that's being done so that you can actually pinpoint cancers. There's a paper that came out through Google where they were able to, at a much smaller number of pixels, identify anomalies with a slightly higher percentage accuracy than a human. It's a small improvement, but it's an improvement. And it's not taking away from somebody's job so much as it's allowing those who are reviewing these scans to have increased accuracy in the work that they're doing, to turn around results faster, to possibly save money in terms of diagnosing. We see it in terms of implementing it into products and services that companies are providing. ImageNet is a very well-known competition that was taking place for several years and was just retired recently, where they were, in essence, trying to make strides in image analysis and classification. And that led to these algorithms that were performing very strongly in classifying images, in image search. And companies were able to take that and implement it into their products. And Google has implemented it into when you show your phone, and specifically the assistant on an Android, whatever the camera can catch, it will be able to give you an idea of what it thinks it is. It's kind of fun. I did this with Siri a couple years ago where I would ask it lots of questions, and so now I've been playing around with the phone and being like, what is this object? And it's fun to see what it comes back with. But this is a great example where companies are seeing the opportunity to take this and build on it. It's a foundational component. It's not the end game. It's a start. We have claimed that it is now an AI-first world. Most companies, most Fortune 500 companies are saying that this is something that's a priority for them to incorporate. We are doing that from the perspective of we're incorporating it across the board in multiple products, multiple projects. So it's not just in, taking it and applying it in Google Lens. It's applying it to search. It's applying it to the way the photos are organized. We're applying it to Gmail. We're applying it to multiple products, and we're not the only ones. Companies are seeing this as a space to say, take AI, incorporate it directly. But we don't just incorporate it directly. We look at it from the standpoint of indirect improvements. Google took work that DeepMind was doing, and DeepMind's a well-known company that we acquired several years ago that was making advancements with Atari, with reinforcement learning. And it took that algorithm and that approach and applied it to analyzing cooling usage in data centers. And we were able to reduce our cooling usage by 40%. That's huge. Because that's just one example of where companies are looking at how to analyze their infrastructures and save time, save money, improve operations. And there's many different ways to do this. It's just beginning. So there's hype. There is a lot of hype. But there is real application. So there's a reason why we have this hype. Every time we have any type of breakthrough, it drives up the hype again. And you have to be practical. You have to be pragmatic. You have to understand that there are limitations. And I know you guys talked about this yesterday, but when you get a model that works, it is brittle. It's not perfect, and it won't adapt quickly. It has limitations. It is limited in its ability to solve very complex problems. It takes time and effort. It takes a lot of data to really make most of these models work. And so if you're trying to throw a new complex problem at it, you will probably spend a significant amount of time helping define what that problem looks like and the data that needs to go into it to solve it. And once you get it working, you won't necessarily get it to quickly change. You know, AlphaGo, it plays the game Go well. But if you were to change a rule in the Go game, you could tell that to the person playing it, and they'll be able to adapt quickly. But the AlphaGo system will take time with a lot of examples to be able to adjust. So it takes time. These models are not quickly adaptable. This is why we're not worried about it taking away all the jobs tomorrow. So where are we going? We want to get to generalized intelligence. We want to get to algorithms that can solve problems and can adapt quickly. What we have, Google in particular has been working hard at trying to take existing algorithms, models that are successful, and make it easier for you to plug them in and play directly into your product. So what I talked about with Lens, where you can show the camera some kind of image and it will be able to come back with a recommendation, we're trying to allow those algorithms to go into products so you can build on top of them. They don't transfer quickly, but they're transferable enough. So democratization right now really is about transfer learning, taking something that's working and applying it to a problem that's similar, and you still have to spend some time with data to get it to work, but it's doable to adjust it. It's a step. The idea behind democratization, whenever you hear people talk about it, is that they want to make it easier and easier, so it will generalize, so it will be quickly adaptable, so it will be something you don't have to spend as much time and effort to figure out how to make it work in the systems that you're working with. That's the direction we want to go in. And it's not just Google. This is many companies out there that are looking at how to commoditize it, commoditize this, how to take this, commercialize it, simplify it, make it plug and playable. And at the heart of what AI is, it's about augmentation. It's about augmenting the companies, the products, whatever it is that you're working on. It's about augmenting you and what you're doing. You don't hand calculate out your calculations now when you do that in math class when you're trying to learn how it works. You use a calculator, you use a computer, so if you can build a tool, you're going to use the tool. And this is a tool. This is going to be a tool to only simplify and improve our lives, especially as we continually create more data. Some great examples of where we're seeing augmentation. You know, I already mentioned about medical, but you look at the genomic side of things in terms of, I think, what was it? You have, I'd written this down, that you've got about 3 billion pairs in a DNA sequence, and that there's a significant amount of data that you're trying to process when you're looking at an individual's genome. And it took 10 years to get there, to initially map out an individual's genome. It takes a day with machine learning. That's a significant improvement in terms of how machine learning can help us in our research, in our processing of the data that we have out there. And with genomics, we're looking at a number of areas in which this can be applied, from how it will eventually allow us to better scan and understand newborns and the potential challenges that they're going to have, to helping us create personalized medicine. Personalized medicine is really kind of the key thing here, where we really want to get to, where we want to see being able to identify specific diseases that a person has and then give them therapy that's going to help them at the end of the day. So machine learning will play a role here, a significant role. It is going to help us advance in this space. And it's going to augment us in this space. It will augment us in two different perspectives here. One, CRM, customer relationship management. We're seeing how companies are engaging with their users and finding better ways to take that information in and create a comprehensive picture so that the sales agents can engage with each of the individuals that come into the system in a much more knowledgeable way. It's augmenting their sales agents. It's allowing them to understand their users and give them the results quickly to simplify that process. And it's helping to analyze their behaviors. It's helping them to understand their uniqueness and give users what they didn't know they wanted. But on the flip side of that, you've also got this perspective from security, where we look at something like Equifax, and we look at other breaches that are happening. I know not only in the US, but definitely in Europe and in all the countries. Breaches are a thing, and you can use behavioral analysis to understand what normal interactions with the computer system should look like, to then identify anomalies that are unique and different. Machine learning will be used from a sales and marketing, it will be used from a risk management, it will be used in multiple areas of your company. It will be used in operations efficiencies and utilities. They recently published a paper about, or this article just came out about this group that is doing freight logistics and trying to help predict, potential challenges and help coordinate freight movement and transportation. I've talked to groups that are working on using devices on their machines to better understand and predict when those machines will fail, to reduce the risk of failure, to potentially save lives, to save energy. Lives are more important. You see this world right now where it's over 8 billion devices in existence for IoT. We expect in the next few years that that's going to more than double. And we know we have so much data coming in from that we can use to help improve and augment the world around us and the way we engage in the world around us, how we use that information. But we need machine learning to help us capture it and help make use of it. Because that's what it's all about at the end of the day, is helping to simplify what we're getting. There's so many of us that are constantly connected, and we're constantly looking for information. And when we have new and new data being generated, you need a faster way to search through that to get to the answer you are seeking. So augmentation, that's where this is going. That's where it is, and that's where it's growing into. It will continually see advancements from an augmented perspective. It's exciting. AI is exciting. It's electricity, but it's also, frankly, turning into this fundamental component that we will use to build on. That is really what I'm getting across. It's what I'm stressing for you, is to understand that, to take that, to build on that, to use what you're going to work on today and go through today, as these are building blocks. And to get there, as I've said before, and I'll say again, you don't go from 0 to 60. You start out and you build. You slowly move through the process of trial and error. You don't get to an AI that is going to be human-like tomorrow. You go through the cranky AIs and the unhappy, moody AIs, and the ones that just can't deal with, it's funny, but it's slightly off-centered AIs. It takes time. It takes research to get down that path. And you need to have a couple of fundamentals. You need to have a well-defined problem, You need to have data, because that's, as I've said, the real key to the success of these models. You need to have the right system set up to do the processing, to do the training of the models, and you need experts, people in this room. You have value. You will continually adapt and learn because this technology is continually adapting and learning. And what your needs are will change, but experts are needed. You can't get them out of the picture completely, and you shouldn't get them out of the picture completely. So our challenges are data and experts. That's actually one of the key, or the two key things. Now, I've heard different arguments for which one's worse. Will we, are we more strapped because of data or more strapped because of experts? Something else that doesn't get brought up enough, in my opinion, is that with deep learning being all the rage, tuning is hard. Tuning is not an easy thing to answer. Everyone wants to know what are the tricks behind it. And frankly, there's a lot of nuance, and we haven't fully mapped out the full space of options for tuning. Not just with deep learning, with other models as well, but tuning is a challenge. And generalizing is key. Being able to take a problem and easily translate it over to, a solved problem and easily translate it over to a new one. Your self-driving car is not going to self-drive a plane, maybe eventually, but right now it's focused on actually driving the car. And it definitely will not, solve your math equation for your homework. It's not going to do your homework for you or feed the dog. It is not human-like. It's not able to understand its existence and what it means when it creates a poem. We can have generative algorithms that are creating poems, but it won't understand the real meaning behind it. So generalizing these actual models and having them understand more depth behind what it is that it is doing is difficult. It's very difficult, frankly. And it will take time and a lot of work to get there. Anthropomorphism is a problem that we are up against across the board. We put these algorithms out into the wild and they fail. They do things that are completely against the grain of what a human would typically do. And it's because it's an algorithm. It's an algorithm that somebody has built. It's been built to do a specific thing. It doesn't have any sense of emotion or social IQ. But we want it to. We want to believe it has that. So we constantly set expectations on what we think that tool and technology should be performing. And it's not doing that because it's not human. And that's a constant challenge we are up against, is setting the right expectations there. Bias. This is my favorite one to bring up. Bias is the biggest challenge we're up against from the standpoint of the data is biased. People who collect the data are biasing the data. The models are biased because the data is biased. Why am I bringing this up? Because you need a diverse workforce to understand and collect data and to see things from a perspective you are not seeing them from. You need somebody who can give you a perspective of, disability. Maybe somebody who's colorblind who can see that if you're showing certain things a certain way that not everyone's going to be able to see it that way. You need diversity in the way you're collecting your information and how you're building these models to test it, to see what kind of results are coming out of it. So these are some key challenges we're up against right now that we have to overcome. So AI, there is some magic, there's excitement, there's a reason to get excited because it does have potential here. It does, it really does. But once you've actually achieved that, it's common for AI to then become not AI, and just a tool. And it will be a tool, a technique, a fundamental building block that you will use to build off of that will take you further faster. So we have narrow AI. We have data that we need in order to be successful. We need data. We need data and we need experts. Democratization, where we're at right now, is literally taking problems or solved problems with our models and applying those models to similar areas, but still needing to do a lot of work and effort to get it to work. But with the efforts of those who are in the space who are researching it, like yourselves, We're working towards making it so that this becomes more and more commonplace. It becomes easier to implement. It becomes easier to plug in. This is a fight that we will see continually evolve into solutions that are going to make our lives a lot more, better. I'm being very hopeful. We need more hope in the world right now. So it's crazy stuff happening out there. So the main thing I want you to take away from this is that where we're at right now, it's good to be innovative, it's good to be excited, it's good to have imagination, and to always marry that with pragmatic perspective, to always think about the realities of what you can achieve at the moment, where you could potentially go to, but the limitations, to keep those in mind, and to just do this delicate balancing act between the two. That's crucial in terms of how you approach AI. You can't lose sight of the innovation and the excitement, but you also need to keep that tempered at all times and just find that balancing act. And the best way to do that is to research. When you don't know something, instead of just assuming, spend time researching the subject, finding experts who can share knowledge with you, exploring things that have already been done. Look to people who especially are leading the research areas as ways to take what you're doing and advance yourself further. That's where you want to focus. Thank you very much. That's all I had for you guys for today, so thanks for taking the time. And I'll take questions.